Okay, so I will share my screen.
Hmm.
Can you see my screen?
Yes, yes.
Okay. So today we are going to start K-means clustering algorithm. So,
Okay.
so first thing you need to understand that this is an unsupervised learning algorithm. So basically, from here we are going to start unsupervised problems. Okay. Just to remind you, what do I mean by unsupervised learning? In supervised learning, with all the training and data, whatever data set you had, we also have that tagged labels, that what are going to be the labels or what are the classes that the data, the vectors belong to. So that information of that class information was there, always there. Whatever or data sets or whatever examples we have seen, in that we already know the labels also of the data. That is supervised learning, because that's supervised, right? You know the class. In
Because
unsupervised
labels,
learning, yeah,
because of labels are there. So
yeah, you know the labels,
with
that it is a
data,
zero
so it is.
class, one class, two class.
Yeah,
Right.
yeah, yeah, yeah. So it's supervised.
Yeah, yeah,
Okay,
that is
okay, okay,
supervised. Now in unsupervised, what happens? In
okay.
unsupervised example, I have told you something like this, that you have data point like this.
Hmm. Okay,
Now you don't know the labels. You don't know what is the label of this. This is circle, or this is square, or this is plus. You just have this unlabeled data. You just have the unlabeled data. Now the,
so X and Y axis is not defined.
yeah, x and y is defined. X and y is defined. X and y is some features.
Okay.
These are features.
Mhm.
Features. Some features. But
Okay,
I don't know the class. I don't know which class it is. The class information is missing actually. Okay. So now what I mean to say is, in unsupervised learning algorithms, like K-means is one of the famous clustering algorithm. What we need to find out is clusters. Clusters, or you can say group. Okay. So on
okay,
unsupervised learning will find this as a group, maybe this as a group, and this as a group. If I say that my k is going to be 3, the number of clusters which I have to find is 3 here. You got the point. Basically, in
yes, yes.
unsupervised learning, what we have to find is, we have to find that how many groupings are there, how many clusters are there. Because supposedly the clusters, if there are some few points which are clubbed together in a cluster, then they will be similar kind of items. Right.
Okay,
So for
okay,
that purpose, in an unlabeled data where you don't know the class, you can perform some kind of clustering algorithm to find out the groups. And that is what the prime motive of k-means is. In k-means, the whole objective is to find the group. And as the name suggests, k-means, right? So k means. K-means is basically, you have to provide the k. So here I have provided k equal to 3. If
okay,
suppose I would have given k equal to 6, then maybe it could have found 6 clusters, something like this,
okay.
in group.
So these clusters are same for training and testing data?
See, that's what I am telling you. Like,
Okay,
here, the testing is totally a different thing. I don't have to do testing. As of
okay,
now, you just assume that my purpose is not to do any kind of testing, because
okay,
you do not know the class itself. You don't know anything
Hmm.
about the class, which class is what, right? You want to find
Yes.
groups. You want to find that which are the similar kind of data. Okay. I mean, do not confuse it with a classification problem. It's not classification. It is not at all a classification problem. It is
Okay.
a clustering problem where you have to find that which data points are similar. I will tell you once again. Let us suppose um, you have say 100 data points. 100 data points.
Data points.
Yeah. Suppose these data points are nothing but height and weight of people. Of people. Now,
Okay.
if I ask you that in this 100 data point, find out which people, I mean, what kind of people are of similar body type. Okay, if I say
Yeah.
that in this population, you have to find out which are the people who are of similar body type. So what you do, what you will do, these 100 points will be scattered something like this. I mean, this is let's say weight, this is let's say height.
Hmm.
So these all these 100 data points will be lying somewhere like this.
Yes.
Now our purpose is to find out which are the people who will be similar in body structure. So what I will do, I say that okay, I will say that okay, in the population of 100 people, let's say I will have five kind of groups. I mean, five body structure. One who have less height and less weight. One who have like more weight, very I mean high weight, but maybe the height is not that good. Maybe very
Okay.
less weight, but height is very good. So similarly, say let's say I kept that okay, five kind of people will be there. Now k-means, what is this k-means? The k-means algorithm is so good that it will find out the five clusters for you, the clusters which are similar, where the data points are clubbed together. So now after finding these five clusters, I can say that these data point these 10 20 data points are of similar type, this data point is of similar type, this data point is similar type, this is similar type, and this is similar type. So the problem is of clustering here, you got it.
Yeah. Yeah. Yeah.
Now we will see how actually, now till now you might have understood that what is the problem statement and what we need to do. But as a machine learning algorithm, we will look into k-means algorithm, how actually it does that. That is very important to understand. Okay. So
Okay.
how does this actually do that? See, this is an example that how supervised learning looks like and how unsupervised learning looks like. In unsupervised learning, basically the point is that you do not know the class. So it's all homogeneous. It's all dot 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 dot. And there is no label in the training set. Here, your training set also consists of y's. You will also have y. Here, you don't have y. You have only x. Right.
Okay.
Now,
Okay.
now we will go. We will see that how this k-means clustering algorithm works actually. So let us start from this place. Can you see green circles here? Small circles, green.
Yeah. Green circle. Yes.
Now, as of now, can you identify just by seeing the dots? Can you identify that which ones are similar? No, because I mean, what I mean by similar is right now you just by seeing the data, you cannot say that these data points are of some class and these data points are of some other class. Exactly. You cannot say that.
Yes.
Why? Because everything is green only. No? Green circles are there. It's not like a supervised algorithm where you already know that what is a class. Here you don't know. It's unsupervised. So now how
Oh,
this k-means algorithm finds out the cluster in the data? That's an important and interesting to understand. That how this k-means works. So let us start what it does. As I told you, first of all in k-means you have to give the k, that how many data points you want to generate. Right? I mean at the start you have to give the k. K is basically yeah, okay. I quoted it wrong earlier. In k-means, k is basically what? The number of clusters you
number.
want to find in the data. Okay. So let's say I say that k is 2. So in k means the parameter k is I have kept 2. Okay. So now you see what k means does is it will initially form two groups randomly. Randomly it will form two groups like this.
Okay.
So it what it does is actually it puts a center here and a center here. At two places it put the center initially. And why two crosses only? Because I have given that parameter k equal to 2. Okay. Now this k equal to 2 centroids it will place. Now what it does a very interesting thing. For each data point it will calculate which one is my nearest centroid. So tell me, this will belong to which centroid? This will belong
Mm,
to the red one.
okay.
Why? Because it is more nearer to this centroid. And remember,
Okay.
these two crosses have been chosen randomly. So randomly choose at any place and then assign all the data point to some or the other clusters. I mean centroid. Assign all the data points which are near to this as a red thing. And all the data points which are near to X, they will be assigned like this. Okay.
Mhm.
All the data points are will be like this. So basically what I mean to say that is this. See. Can you see this?
Okay.
Now, see, initially I put a red and blue data points. For each data point, you calculated which one will be nearest centroid,
Yeah.
and then
Yes.
assign the same color as the centroid have. So you see, this is the thing which comes. This is like you have this X, and these are the red ones are the one which are near to X, and the blue ones are near to blue. This completes the first iteration of this k-means. First iteration. Similarly, iteratively, you will go and go and go and go on, and you will certainly find the two groups totally separated. Now, in here, now this is the first initial, setup. Now, what next? Now, as you can say here, there are these red points which belong to the red centroid, right? Red cross. In second step, what happens? You will take an average of all the red points. Take the average. And the average, whatever will come, let's say it comes here. So the centroid will be shifted here. And suppose the average of this blue lines comes out to be here, so this will be shifted here. These will be the new updated center. New updated center.
Updated.
See, like this. So for all the data points which were lying in the red, uh, all the data points which were lying in the red centroid, we calculated the mean of all the data point, and it will shift. Okay, the centroid will shift to some other position. Okay. Now
Okay.
the blue ones. Similarly, take the mean of all the blue data points, your centroid will shift here. Okay. Now reassign the data points again. Again check which one is the nearest. For each data point, in each circle, just check that which is the nearest centroid to me. Okay.
Okay.
So
Okay.
now if you will do that, you see, can you see the difference? Just look at this data point. This data point. Now this is nearer
Hmm.
to this one or this one?
Blue one.
This one is nearest to this one or this one? Blue one, right?
Blue
So
one.
if you
Yeah.
see the next step, these data points will become blue. See?
Nearer data point. Okay.
Yeah. For all the data points you have checked simply that which one is nearest and you have given that. But as your new assignment has been done, again you need to recalculate your centroid, update your mean. Right. So again you update
Right.
your centroid and it will move here. This moves here from here, this moves here from here. And then again you have to reassign the things. Again you have to reassign.
Reassign.
So see what happens. Now again you need to calculate the mean, updated mean. So it comes here. So finally you got this. Now again if you reassign you will get the same thing. If you go for any kind of centroid updation or something, it will be same. This is the condition where we have finally reached, where I have now clearly two groups. One group is this and one group is this. So you see the k-means has done that thing for me. K-means has, starting from a two random centers, it has started from two random centers. And
Okay.
see, there are two steps. There are two steps here.
Two.
First, cluster assignment. First, cluster assignment. Just give me a moment. Huh? I will.
Okay. Okay.
Yeah. Can you hear me?
Okay. Yes. Yes.
Yeah. So the first is cluster assignment step, and the second is cluster update.
Centroid.
Cluster mean update. Here I am calling this as a cluster, and this one is the mean. Okay. This as a cluster and this one is a mean. So these two steps, keeps on repeating until and unless you find that there is no change now. Now from here where
Okay.
it can go. If you will recalculate the assignment, these points will be assigned to this, these points will be assigned to this. If you calculate the mean, it will be same. So it will stop changing now. So the whole idea is that you keep on doing the cluster assignment, and so start with a random position. Start with any random position, then do cluster assignment. Assign all the data points to the nearest cluster, whatever it will be. Then what to do? Then update the mean by taking mean of those things. And then once the mean
Okay.
are updated, again assign the data points to the nearest cluster. And keep on doing the same thing. Again update mean, again assign, again update. Keep on doing this thing until you stop. Finally you see that there is no change. You got the k-means algorithm, how it works?
Yes, yes.
This,
Again,
this
assignment.
yeah.
Again, shifting the data points every
No,
time.
data point is not shifted. The mean is shifting actually.
Mean is shifting. Okay. Data points remain there.
Data points
Yes.
remain there. Data assignment, data points are assigned to the nearest cluster. Whatever is nearest, it will get assigned.
Okay.
Like the red and blue I saw,
Mhm.
See the data points, just the colors are changing because of the assignment. So just remember this point that each data point will be assigned to the nearest thing, nearest cluster. It's not like that this data point will also belong to blue somehow. The nearest, whatever is nearest, it will become of that color.
Okay. Okay.
You got that point?
Yeah.
Yeah. I will show you through Python code also how this thing works. Okay. Maybe with some data set and some examples. But you just understand that this is the way it goes. First randomly take cluster center, then assign to the nearest, then again update mean, again assign, again update, assign, update, assign, update. This thing carry on until you stop. This is your
So,
k-means algorithm. Good
so
enough?
what is the, yeah, but what is the final condition when it should stop to
I tell you that
changing?
mean is not changing now. At one point, there are
Mhm.
two things. One, you limit the number of iterations. One, you limit the number of iteration. You just say that I will do this k-means for 100 iteration, and that's it. Whatever may be the case, whether it has clustered well or not. But you say I will go for 500 iteration, that will be enough.
Okay.
Or
But,
second thing is,
yeah.
or the second thing is, once you get the clusters, once you find the clusters, like here in our case we found the clusters, you will find that your cluster mean is now not changing. Your cluster mean is not changing. That you will
Not
find.
changing.
So when the cluster means are not changing, it means the iterations are complete, the process is complete.
Okay. 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 But what if there are huge number of data points?
Yeah, in that case only, na, it might be possible there are huge data points, huge number of data points, and so the important thing is if they are actually in the data points, if they are actually clusters, it will find that, and with more data points, with a huge number of data points, this k-means will become little slow also, because
No.
each and every data point it has to assign to a cluster and then take the
Okay.
mean. Okay, mean is not, I mean, time taking thing because it's just a vector mean or something, right? So mean update is fine, but assignment step you have to go through loop for all the data points in order to find out that which data points are, I mean, belong to a similar kind. I mean, similar
Okay.
falls in similar cluster. So if you have a huge number of data point, k-means will be little slow, but you take more number of iterations. You take more
Hmm.
number of iterations, maybe take 1,000 number of iterations. Let's see if it can cluster it or not. Okay.
Yes. But every time it's divided into two clusters,
No, no, that
or it will be
k-means k is there, no? In
okay.
k-means you have a parameter k. You see this one,
Okay.
this one.
Okay.
In
Number of
input, you
clusters,
will give the
basically.
training data point and you will give the value of k. This k will tell you how many clusters you are going to find.
So minimum you have to provide two.
At least, of course, at
Okay.
least two. To, there is no
Okay.
meaning of one cluster, no. One cluster is like
Yes. Yes.
data.
Yes. Yes.
Okay,
Yes. Yes. Yeah.
so like that, you will give the input as k and the training data, and you will get the model. I mean,
Okay.
theoretically, if you want to see how k-means algorithm, what is k-means algorithm and which we have seen pictorially, you see this is the k-means algorithm. Randomly initialize k cluster centroid first, cluster mean basically. So randomly initialize k cluster method, and then repeat that both the step cluster assignment and then this centroid update, mean update.
Okay. Okay.
In cluster assignment step, you see all the data points are assigned to the nearest cluster closest to xi or whatever, right? And uh, in the move step, you see in the centroid step, you just take the mean of all the points assigned to cluster k. So all the data points which are assigned to cluster, say A, they will be, I mean, we will take the average of them, all of them.
Okay.
Okay. So basically, there are two steps: cluster assignment step and this one, centroid update. Okay. Now,
Okay.
let's see. Now there can be situations like this also. You see on the left hand side, it's very easy to cluster the data. Why? Because these are, intuitively by seeing only you can tell that these are the three clusters in this. So this is
Yes.
like the separated clusters on which you will perform k-means and it will uh, model that thing. But on the right hand side, just see, they are just data points. They were just data points, which when you apply the clustering algorithm with k equal to 3, right, it has found three data sets within, three clusters within, right?
Yes.
And this is like an example of t-shirt sizing or shirt sizing, you see. When you go to the showroom, right, you
Yes.
will find just maybe a small, medium, and large. Three kind of shirts or whatever you are going to buy will be there. Small, medium, large. Maybe XL is also there, extra large and all. That's all 4 to 5 choices we have, right?
Yeah.
Right. But actually, if you see, eh, I mean, actually, this is called as market segmentation also. That any company, say whatever, like John Player or Levi's or in these companies, they will just take the historical data, whatever
Hmm.
selling they had done already, and then they used to analyze this, that how many people are, so mostly people will buy medium size. So what are the sizes actually, I mean what are the clustered sizes, they actually all these companies analyze and find out. Initially, what used to
Yes.
happen, there actually when you see this, you will have the tailor. Now tailor will stitch the trousers and all sizes, 31, 32, 33, all waist sizes. Now this private parties, say Levi's, they thought that why are we going to, spend so much on making all the sizes. Just try to find out what are the common sizes which people buy, and that's how these things have come up very nicely, because they found out that people more or less uh, wear these five brands only: small, medium, large, extra large, maybe XXL.
Okay. Okay.
But the whole point here was to, on the right hand side, if you see, if you remove the circles, you will find that it's general data, nothing, no clustering kind of thing. But as you have done clustering on that, it will form the clusters at least. Good enough?
Yes. Yes.
Okay. So, okay. Now, one more question which will be there is like how to choose K, right? So
Yeah.
for like, yeah. So how do you choose K? Whether to take K equal to 2, whether to take K equal to 5. How do you choose the K? That's an important question which may come to, once you will implement. Of course, you will find that I have to give K, and how do I find the K? So for finding out what will be the K, this objective function, the optimization objective function is very much important here, and I will tell you. Okay, let me first tell you the random initialization part. So this is very simple thing. As I told you that initially, you see, can you see these clusters?
Yes.
Now, how many clusters are there on the top one? Top graph,
Two.
two clusters, right? Now, random initialization in clustering, I told you, right, in the first step only, when you have been given some data point, unlabeled data point for which you don't know the class. So, what I told you, that the first step is random initialization. Randomly take any parameter and you know that choose that those things as a center. So randomly choose the two centers and do. Now my question is, there can be chances where you are randomly choosing the cluster centers and both the cluster centers randomly are chosen like this in the same cluster. So this is a wrong initialization, this is a good initialization, isn't it? It may
Mm,
happen that you are randomly choosing something, right? So the random
yeah.
centroid can go into the same cluster also. Then this will go very wrong, and the model will get corrupt. But if you actually start with this, then it is good. Then you will maybe reach here, and you will form a cluster here and a cluster here. Okay. So random initialization in k-means is a problem, and that is why there is some algorithm also. Maybe we'll not talk about it much, but advanced version of k-means is called as k-means plus plus.
Okay.
Here we do
What?
not do random initialization, but we what we do is that once you have chosen one center, suppose you chose one center here, then the second randomly center which you have to choose will be far from the first one. What I am trying to say is, you just try to understand it. What I am trying to say is, if you have the data points are like this, right? Now suppose you chose the first cluster center to be here. Now just make sure that the next data point wherever you are choosing is in the same thing, same cluster. If that is the case, this is wrong. So in k-means what in k-means plus plus basically what they do, if they chose one point here, they will choose the other point at far distance from this one. So this kind
Okay.
of initialization are done in more advanced k-means methodologies. Okay.
Okay.
So random initialization you see again see in here also you can see both the cluster center have unfortunately randomly selected as
Two.
this, which is wrong. This is a perfect clustering. See, this is wrong. In just one cluster, both the centers have come. So then it is very hard. Maybe this will form this cluster and this will form this cluster. And that's it.
Okay.
So that is random initialization. And what I was telling you is choosing the number of clusters, this one. And how do you do that? Okay, choosing the right number of k. Can you see this image?
Hmm.
What is the right value of k for this? Here, how much k? What is the value of k here?
Two.
Hmm?
Two.
2, right? But actually, that's what I'm trying to say. Even if you take k equal to 4 here, there is no problem because then one group will be this, another
Hmm.
group will be this, one group will be this, and another group will be this. Now k equal to 2 we should choose or k equal to 4 we should choose. So for that to decide, see mostly what I have seen, what from my experience I am telling you, this k you have to give based on your knowledge about the data.
Okay.
Okay,
How?
are you getting my point? So mostly wherever I have applied K means I knew that okay there could be 3 cluster or 4 clusters. So that K values on that K values you have to, I mean, cluster the whole data set will be clustered in that number of Ks whatever you give.
But what is your deciding factor
Yeah, yeah. So
to?
that's what I was coming to. That is called
Okay.
as elbow method. What is the method called? Elbow method. So if you see the elbow,
Okay.
yeah, if you see the elbow from shoulder to the elbow, it comes very fast. The slope is very much. And then from elbow
Hmm.
to the fingers, the slope is less. Kind of this. So what it suggests that you start from k equal to 2. Okay.
Okay.
So for choosing what number to choose for k, that is decided that here I am deciding by elbow method. How? You start with k equal to 2. Okay. You start with k
Okay.
equal to 2. Then go to 3. Then go to 4, 5, 6, 7, 8 like that. Now you will observe, you yourself will observe that taking k equal to 2 then taking k equal to 3, 4 like that, you will certainly feel that at a particular k value, after a particular k value, the change is not much. Okay, After the
Okay.
particular k value, the change is not much, and that is why it is decreasing very slowly now.
Okay.
Okay. So with k equal to 1, you will find, maybe you will find that the objective function has a very high value, the cost. Cost will
Hmm.
have a very high value. I will tell you what is this cost. Then for k equal to 2, you will find that the cost has decreased suddenly. K equal to 3, you found that the cost has even decreased suddenly. But after k equal to 3, what you are seeing, that this is not decreasing actually, or decreasing it with very less difference. It's more
Okay.
of a like a parallel line only, na? So there is no much
Hmm.
difference. So what actually I was telling here, I will choose k equal to 3 simply. Why k equal to 3?
It's not decreasing. No, there
Because
is no difference.
after k equal to 3, it was not decreasing much. Till, see, till you take k equal to 2 and you take k equal to 3, which one is better? Definitely k equal to 3 will be
Yes.
better, because the error is very less.
Yes.
Okay. Uh,
Yes.
it has changed a lot, then it has changed a lot, then now it is not changing. So at that elbow, we call it as that is the k. That will
So
be my,
4, 5, 6.
yeah.
So 4 still it's decreasing 4, 5, 6. A slight decrease is there.
Hmm.
You took 4, 5, 6 number.
Yeah, those will be decreasing, but not much.
Okay.
Okay. That's how. Now, the last thing. What is the cost function here? The cost function is sum of all the data points from their cluster centers. The sum of all the data points from their cluster center and Euclidean distance. This is my cost.
Okay.
So if you have, say, 10 data points like this, you consider it like this only, na? Like this is the data point, right? So suppose the cluster center is here for this and here for this. So the cost will be all the data points, all these black, this one, these black data points minus the cluster centroid one. Okay, and
Mhm.
this is also squared over. So whatever this distance is, na, this distance is basically calculated. This distance is calculated. So the data points from their center. Now this distance will also be get calculated. And these are all summed up. And that is your error basically in k-means. That is your error in k-means.
Uh,
But that is only used here as a cost function in order to find the correct k. There are other also methods for finding the k value, but this one, album one, is most popular. Okay.
Okay.
Now you see in here the same set of data. The data has not changed in here to here. The same data, one company has put k equal to 3. So it has made 3 sections, 3 groups on whatever transaction it was doing. Right. Now, the same thing has been designed by another guy. Okay. But with 5 classes. extra small, small, medium, large, extra large. So the same, the circles, you see how it has splitted. Okay.
Mhm.
So it depends upon the analysis whether you want to do 5 sections or 3 sections or 4 sections like that. So do you, I mean, I hope you understood the whole funda of K-means.
Yes, yes,
This is like random.
yes.
You see, this is the objective optimization objective I was talking about. Can you see this formula?
Yeah.
This is basically 1 upon number of training example. The simple linear regression cost function was there, no? Like, so these are the data points and these are the respective centers. Okay, so this is the error basically, which now our aim is to put the center at those places where this distance gets very minimum. Okay, we have to basically minimize this objective function. So we have to place our centroid, keep on updating, and place our uh, the centroids such that this objective function is minimized. Of course, as the clustering is done, as the clustering is progressing, you will find that this particular parameter or cost, whatever you are saying, this gets better and it decreases actually. Okay, good enough.
Okay, okay.
So
So where this is used? K means.
yeah, came in. Yeah, so that's what I told you. Like in market segmentation, in lot of like I used in a speaker problem. I mean in a speech application also to basically to find the similar kind of segments. I
Okay.
took K-means. Like suppose right now we both are talking, right? Sometime I am talking,
Mhm.
sometime you are talking. Okay. Now suppose with the whole 1 hour audio I took and I chop it in some time, say 2 2 second time I chop the whole 1 hour video. So so in that if I chop 2 2 seconds like of yours and like mine, maybe there will
Mhm.
be numerous in 1 hour. Maybe there will be hundreds of point like chunks, 2 second chunks or whatever. But so what I used to do is once that you chop off the whole speech, then the chopped off segments we try to cluster. So whatever chops with whatever that size, whatever size you have taken, the chunks, 2 second chunks,
Yes.
whatever I have spoken, they will come together, and whatever you have spoken, that will come another in another cluster. So
Okay.
I used to do it just to find out that what are the utterances which I have spoken. Similar kind of utterances. This is just one
Okay.
example, and I also told you the market. You see the market segmentation problem,
Okay. Okay.
social network analysis. Organizing clusters in a supercomputing facility, some astronomical data. I mean, You can find numerous applications of k-means also. Uh, Maybe like this. Majorly, what I would say is k-means is a clustering algorithm. So whenever you have to find similar, what are the similar kind of data points, then you have to do this clustering.
Okay.
Okay. So when you
Okay.
just remember this, whenever you have to find the similar kind of thing, and you don't have any class or you don't have any labels, nothing. It's all unsupervised. Just what you have is data.
Yeah.
Okay.
Okay. No labels and nothing.
No
Only data
labels,
is there.
nothing. And you find you want to find that in among this data, what are the data points which can be which are of similar type. Maybe for market segmentation, maybe for social network analysis, maybe for my speaker ID problem.
Yeah. Yes. Yes.
And we will see the examples also, okay? I
Yeah.
mean, don't worry about it. We will see numerous two example and then one again, one practical text classification problem is there. So yeah,
Okay.
maybe two, three examples we will see. It will
Okay.
clear even it will clear the whole picture one like on the practical side also. Okay.
Okay. Okay. Okay.
So